Hey, Algebra 1, Mr. Catlin here with your help for Lesson 8, and I'm going to go ahead and throw in Lesson 9 in there as well. I posted a video for Lesson 8 yesterday, but I made a little mistake whenever I was comparing the final part. So I'm going to take my shown work that I had with the adjustments and just kind of talk it through. So on Lesson 8, we start writing these expressions that are equivalent to the quadratic expression that's given, and we have a couple of strategies that we use to multiply these two things together. The first strategy involves us thinking of the two things as being the length and width of a rectangle. So I'm multiplying 3x plus 1 times x plus 2 quantity. And so I think of 3x plus 1 as the length, I think of x plus 2 as the width, and I set up a rectangle that has x plus 2 as a width and 3x plus 1 as a length. And so the whole area inside should represent the product of those two things being multiplied. But since the length and the width are broken up into terms like 3x and 1 and x and 2, I kind of have to break up my lengths into those amounts. So think of this section as 3x and this is 1. This length is x and this is 2. And so I've broken up this entire rectangle into 4 like smaller compartments on that one big one that I can add together later on and get a final answer. So x times 3x gives me 3x squared for that area. 2 times 3 x's gives me a total of 6 x's. 2 times the length of 1 gives me 2 down here. And x length times 1 length gives me 1x for the area inside this section. So when I add the 3x squared and the x and the 6 x's and the 2 all together, I have two parts that can come together as like terms and create 7x because 1x plus 6x is 7, which gives me my final version of this as 3x squared plus 7x plus 2. Now, that's one strategy to write it out as an area of a rectangle. The other strategy that you can use is to think of this thing called FOIL, and I've written it out here, FOIL. Whenever you're multiplying these two things, every part inside of the parentheses is getting multiplied by the other part in the other side. 3x gets multiplied by both of these parts. 1 gets multiplied by both of these parts, and vice versa. So to keep up with what you've multiplied and what you haven't multiplied, there's a little strategy called FOIL. F stands for the first, O stands for the outside numbers, I for the inside terms, and L for the ones that come in last in the problem. And it's kind of hard to see here because I wrote over top of it. So let me erase what was there. Okay. So the first part, whenever we write this out, let me rewrite it as it was. X plus 4 squared is really the same as taking the expression x plus 4 and multiplying it by x plus 4. All right, and these two things are getting multiplied. So first are the numbers that happen first. X and x are first in the parentheses. So we multiply x times x for the first. And then the outside numbers are 4 and x. Those numbers are on the outside parts of the parentheses, on the far left and the far right. So x times 4. And then comes the inside pair, which is 4 and x. They're in the middle. 4 times x, which you see here, 4 times x. And then the last numbers in the parentheses. 4 is last and 4 is last. So 4 times 4, which gives us the 16 that we see over here. So x times x gave us x squared. X times 4 gave us 4x. 4 times x gave us 4x. And 4 times 4 gives us 16. And then, like we did before, when we combine our like terms of 4x and 4x, we get 8x. And we end up with this expression of x squared plus 8x plus 16. And the question says, is this equivalent to this expression? And we're showing here that they are not equal. X squared plus 8x plus 16 is not the same as 2x squared plus 8x plus 8, as that has a 2 in front of its x squared, which ours doesn't, and it has an 8 in the last term instead of 16, which ours does. So these are not the same, and I believe our shown work here is enough to prove our reasoning of why they're not the same. So let's move into the last thing that I wanted you to do for lesson 9, which is just some extra practice of this skill. I'm going to do the same thing, one in the form of a diagram and one in the form of using the FOIL method. So let's start off with the diagram. So let's draw this rectangle. Go over here and there. And there we go. What a beautiful rectangle I've drawn. And you know what? I have the technology to draw one with straight lines, but I choose to freehand it, which I think says a lot about my character. Let's look at 2x and 5 as being the longer side because 2x's is more than 1, so that kind of makes sense, right? So let's call this 2x, and we'll call this 5. And then on the width part, we'll call this section x, and we'll call this 1. Okay, so both parts have been represented. This is going to be my length. This is my width. We're multiplying, and the area should be what their product is. So let's multiply. X times 2x is 2x squared, because x times x is x squared. X times 5 is 5x's. 2x times 1 is 2x. And 5 times 1 is 5. So when we write this out, we get 2x squared plus 5x plus 2x plus 5. When we add all the four compartments together, the like terms make 7x in the middle. And we have a final answer of 2x squared plus 7x plus 5. And there we go. We have our final answer now in standard form as they wanted it expressed from its factored version. So factored has parenthesis parts like this that are multiplying two things. And when it gets multiplied out, it becomes into its standard form where the terms are being added or subtracted together, and we lose the parentheses in the multiplication. Let's look at the next one, and let's do this one using FOIL. So if we follow the FOIL strategy for this one, we're going to do first, okay? So the first terms here are x times x. So I'm going to show my shown work. Plus, the next section are the outside terms, which are x and 2. And x times 2 is shown like this. It's also equivalent to 2x. Now my inside terms, be careful. This minus makes that 2 negative, so this is negative 2 times x, which gives me negative 2 times x. And then in the last part, negative 2 times 2. There we go. I got it all written out. X times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. And negative 2 times positive 2 is negative 4. And when I combine these two parts right here, they actually cancel out because they're additive inverses. They make 0, so they're gone. And I get x squared plus a negative 4, or just x squared minus 4. And there you go, guys. There's your help for your homework video. I hope it was helpful, and we'll see you guys tomorrow. Don't forget quiz over lessons 1 through 9 for Algebra 1 classes tomorrow. See ya.